Hello everyone. Let us see the solutions for Polytechnic Lecturer Examination held on 2012 by Andhra Pradesh Public Service Commission APPSC. First question. For global communication, the number of satellites needed is 3 satellites are required. A geostationary satellite can cover one third of the Earth's surface. 3 geostationary satellites spaced 120 degrees apart can cover entire Earth for global communication. Let us see some important points related to geostationary orbit. Geostationary orbit is a circular orbit, so eccentricity is 0. The period of satellite in geostationary orbit or geo orbit is time period is 23 hours 56 minutes 4.1 seconds. Approximately it is 24 hours. Next, the altitude of geo orbit is 35,786 kilometers. Orbital speed is 3.07 kilometers per second. The satellite in geostationary orbit appears to be stationary with respect to a fixed position on the Earth. So that means the person standing on Earth can see the satellite in same position. Satellite in geo orbit provides continuous coverage, and the inclination of geo orbit is 0 with respect to equator. Second question. AM broadcast radio transmitter radiates 20 kilowatt when the modulation percentage is 60 and the carrier power will be. In this question, they have given transmitting power PT 20 kilowatt. Modulation index mu is 60%, so that is 0.6. So total power PT is equal to PC into 1 plus mu square by 2 for AM signal. The total power in amplitude modulated signal is given as PT is equal to PC into 1 plus mu square by 2. So given PT is 20 kilowatt, carrier power is PC 1 plus mu 0.6 whole square by 2. On calculation, the total power PC is 16.94 kilowatt. Carrier power is 16.94 kilowatts. Option 3. Third question. In a bandstop filter having RLC series resonance circuit. So RLC series circuit which is in resonant mode. At resonance, inductive reactance XL is equal to XC. The total impedance Z is equal to R. Therefore, output is taken across only resistor. Next question. When compared to first order low pass filter, second order low pass filter has faster drop in filter response. So the gain of the filter below cutoff frequency. So this frequency is cutoff frequency. The gain of the filter below cutoff frequency in this region it is constant. As filter order increases, as filter order increases, first order filter, second order, third order, fourth order, fifth order. As filter order increases, the roll off slope becomes steeper. Here steepness gets increased. So the frequency curve become much steeper, and the actual stop band response of filter approaches to ideal stop band characteristics. So this green line indicates ideal stop band characteristics for the filter. So above cutoff frequency, the gain of the filter decreases by 20 n dB per decade, where n is the order of the filter. For first order filter, 20 dB per decade. For second order, 40 dB per decade. For third order, 60 dB per decade. For fourth order, 80 dB per decade, and so on. As order increases and reaches to infinity, the actual characteristics of the curve reaches to the ideal characteristics. Here it is green. It is shown in green line. This is the ideal curve. So option 3 is correct. Next question. Given initially relaxed RC series circuit with R is 2 mega ohms, given resistance is 2 mega ohms and capacitance is 1 microfarad, switched on a 10 volt step input and voltage across the capacitor after 2 seconds. So this circuit is a series RC circuit with the time constant of series RC circuit is RC. So that is 2 mega ohms and 1 microfarad. So it is 2 seconds. Time constant of the circuit is 2 seconds. and the voltage across the capacitor at, after 2 seconds is. So voltage across the capacitor for series RC circuit is given as Vc of t is equal to V final minus initial voltage e power minus t by tau. V final is the final voltage, Vi is the initial voltage. Here final voltage is 10 volts because it's a step signal, minus 10, initial voltage is 0, e power minus at t is equal to 2 seconds. In the question they have given at t is equal to 2 seconds, we need to calculate the voltage across capacitor. So 2 and time constant is 2 seconds. 10 minus 10 e power minus 1, that is 10, 1 minus e power minus 1. So its value is 6.32 volts. So e power minus 1 is 0.367. So its value is 6.32 volts. So option 3 is the correct. Next question. A satellite earth station. So generally the satellite earth station has both transmitting equipment as well as receiving equipment. Option 3. So earth station generally has transmitters, receivers, antenna and tracking equipment, and the earth station can be located on the earth surface. The earth station can be either fixed or mobile. Strapping is used in cavity magnetron to prevent mode jumping. This strapping technique is used to prevent the mode jumping. So the method commonly employed to avoid mode jumping is strapping. Strapping means to connect alternate anode plates with two conducting rings of heavy gauge touching the anode poles. Strapping helps in achieving only the dominant mode or pi mode. Strapping may cause power loss in the conducting rings, and the magnetron which needs no strapping is rising sun magnetron. This rising sun magnetron doesn't require the strapping. Next, the distance of geostationary satellite from the Earth surface. So for geo orbit, as discussed in the question 1, so the inclination of geo orbit with respect to equator is 0 degrees. With respect to equator is 0 degrees. So here it is 0 degrees, and the orbital distance is 30, 35,786 kilometers, and the mean radius of Earth is 6,378 kilometers, and the radius of geostationary orbit from the center of Earth is 42,164 kilometers, from the surface of Earth is 35,786 kilometers. So in the question they have given surface of the Earth. So option 36,000 kilometers. Roughly it is 36,000 kilometers. So option 3. Next question. A unit step voltage applied at t is equal to 0 to a series RLC circuit. To a series RLC circuit with 0 initial conditions. So it is series RL circuit. Series RL circuit. So for series RL circuit, at t is equal to 0, inductor acts as open circuit. The current through inductor is 0. The energy stored in the inductor is 0. So what is the current is 0 means voltage across the resistor is 0. But at steady state, this inductor acts as a short circuit. Some amount of finite current flows through the circuit. The current is called I. Current I flows through the circuit. So voltage across resistor exists and finite amount of energy is stored in the inductor. So there are two cases, one at t is equal to 0 and at t is equal to steady state. So the correct option is voltage across the resistor at t is equal to 0. Energy stored in the inductor in steady state is not 0. Finite amount of energy is stored in the inductor. The resistor eventually falls to 0. So it is also wrong. The correct option is second one. So it is a series RL circuit, not RLC circuit. Given cascaded three-stage amplifier, gain A1 is 25 and gain A2 is 10, A3 is 4. So for a cascaded three-stage amplifier, overall voltage gain is product of individual stages voltage gain. So AB is equal to A1, A2 and A3. So 25, 10 and 4. Its value is 1000. 250 into 4 is 1000. So gain, this is, then gain in dB is 10 log 1000, that is 10 cube. So its value is, sorry, it is 20 log. Voltage gain 20 log, so it is 60 dB. Next question. The temperature coefficient of metal and temperature coefficient of semiconductor. Generally, metals have positive temperature coefficient of resistance. So that is, as temperature increases, resistance increases. Due to atomic vibrations, it leads to more collisions. Next, in semiconductors have negative temperature coefficient of resistance. As temperature increases, resistance decreases and conductivity increases for the semiconductor. So the correct option is metal is positive and that of semiconductor is negative. So option 1. Next question. End fire array, the principal direction of radiation. So there are four different types of arrays. One is broadside array, end fire array, collinear array, and parasitic array. In broadside array, it is an arrangement in which the principal direction of radiation is perpendicular to the array axis. So this is a broadside array. In end fire array, it is an arrangement in which the principal direction of radiation coincides with the array axis and or it is along with the array axis. Correct option is 3. It coincides with the direction of array axis in an end fire array. In broadside array, it is perpendicular to array axis. Option 1 is for broadside array and option 3 is for end fire array. Next question. Given series RLC circuit with resistance 2 ohms, inductor 1 millihenry, capacitance 0.4 microfarad, then quality factor Q. So quality factor Q is equal to omega L by R for series RLC circuit. Omega L by R 1 by omega RC, or 1 by R root L by C. So quality factor Q is 1 by R is 2, square root of L, 1 milli, 10 power minus 3, capacitance 0.4, 10 power minus 6. So its value is 25. The quality factor is 25. So option 3. Next question. Given in an F1 layer of an ionosphere, F1 layer of ionosphere with maximum density is 2.3 into 10 power 6 electron per centimeter cube. The critical frequency of the F1 layer in the ionosphere. So we know that critical frequency Fc is 9 square root of n maximum, number of electrons or maximum electron density. So given maximum electron density is 2.3 into 10 power 6. Therefore critical frequency is 9 square root of 2.3 10 power 12. So centimeter cube is converted to meter cube. So its value is 13.6 megahertz. So option 2 is the correct one. Next question. In a Hartley oscillator, the frequency of oscillations is given by. So this is a representation of Hartley oscillator. Hartley oscillator. Its frequency of oscillation is given by one. The tank circuit consists of three elements. One is two inductors and one capacitor. The frequency of oscillation is given as 1 by 2 pi square root of L equivalent into C. L equivalent is L1 plus L2 plus 2M. M is the mutual inductance between the coils. So the condition for sustained oscillation is the gain of transistor. So here transistor is given. This is a NPN transistor with common emitter configuration. So for this NPN transistor, the gain HFE, forward current gain, should be greater than or equal to L1 plus M by L2 plus M. Then only the oscillations are sustained, and the sustained oscillations has frequency of 1 by 2 pi square root of L equivalent into C. So the correct option is 3. Next question. In a low level amplitude modulation system, amplifiers following the modulated stage can only be Class C amplifier. In low level amplitude modulation system, the Class C amplifier follows the modulated stage. Next question. In a linear circuit, the principle of superposition can be applied to calculate. So we can able to calculate voltage and current, but power calculation is not possible with the help of with principle of superposition, since power is a non-linear parameter. So correct option is 2. So see the definition of superposition theorem. It states that in any linear bilateral network having multiple independent sources, the response across any element in the circuit is equal to the algebraic sum of responses of that element by considering each source at a time, provided remaining sources are replaced by their internal resistances. So this superposition theorem is not applicable. The superposition theorem is not applicable for a networks containing nonlinear elements, for circuit having initial conditions, and for power calculation, since power is a nonlinear parameter. So option 2, it is applicable only for voltage and current calculations. Next, spectral density of white noise. So white noise is constant. So this is a power spectral density of white noise. This value, the power spectral density of white noise is constant. So n naught by 2, that the value amplitude is n naught by 2 or kt by 2, that is two-sided power spectral density of white noise. And the autocorrelation function of white noise is impulse. So power spectral density of white noise is constant. Correct option is 2. Next question. The self impedance of thin half wave dipole antenna. So thin half wave dipole antenna impedance. So input impedance of half wavelength dipole is 73 plus J42.5 ohms. Similarly, the input impedance of quarter wavelength lambda by 4 dipole is 36.5 plus J21.5, half half wavelength dipole. And the radiation resistance is 73 ohms for half wave dipole and 36.5 ohms for quarter wave monopole. So the correct option is 3. Next question. Which of the following circuits cannot be used to demodulate the SSB-SC signal? Single sideband suppressed carrier signal. So for generation of SSB-SC waves, phase discrimination method and frequency discrimination method is used. So phase discrimination method or filter method, phase discrimination or phasing method or phasing method or phase shift method, frequency discrimination method or filter method is used. For demodulation of SSB-SC waves, synchronous detector, product modulator, and balancer modulator is used. So the correct, which of the following not used is phase discriminator. Correct option is 3. Next, the signal to noise ratio of DSB-SC, signal to noise ratio of DSB-SC is dash that of SSB-SC. So signal to noise ratio of DSB-SC is double that of SSB-SC. So signal to noise ratio at the input here is AC square P by 2 N naught W. For SSB SC signal to noise ratio at the input is AC square P 4 by 4 N naught omega. Here input signal to noise ratio of DSB SC is twice that of SSB SC. Input output signal to noise ratio of DSB SC is twice that of SSB SC. So generally they have asked signal to noise ratio of DSB SC is double that of SSB SC. Next question. So, so here it is a note point, the figure of merit of DSB-SC. So output signal to noise ratio by input signal to noise ratio. So this is input signal power, input noise power, output signal power, output noise power for DSB-SC. For SSB-SC, input signal power, input noise power, output signal power, output noise power. So input signal to noise ratio, this one, output signal to noise ratio is this one. Figure of merit is output signal to noise ratio by input signal to noise ratio. And the figure of merit for DSP-SC is 1. Similarly, the figure of merit for SSB-SC is also 1. But input signal to noise ratio or output signal to noise ratio of DSB-SC is double that of SSB-SC. Given signal f of t is equal to minus f of minus t. So the signal itself is a odd signal. For odd signal, Fourier series of f of t contains sine terms. Option 4. Similarly, for even signal, f of t is equal to f of minus t, that is even signal. For even symmetry signal, the Fourier series of f of t contains cosine terms as well as DC component, constant, DC constant. Next, So f of t is equal to minus f of t minus capital T by 2, where capital T is time period. So this signal satisfies half wave symmetry. In this case, the Fourier series of f of t contains only odd harmonics. So odd signal plus half wave symmetry contains odd harmonic sine terms. Odd signal means only sine terms, plus half wave symmetry means odd harmonic components. So if signal is both odd signal and half wave symmetry, it contains odd harmonic sine terms. If signal is both even and half wave symmetry, it contains odd harmonic cosine terms. And DC half wave symmetry means no half wave symmetry means DC component is 0. Next, medium wave broadcast is used for regional service. Medium wave broadcast is used for regional service. So medium wave broadcast signal is nothing but a AM signal, and it is used for regional broadcasting. So medium wave broadcasting or medium frequency broadcasting mainly used for AM radio broadcasting. Some standard specifications of AM radio are, so operating frequency is 535 to 1605 kilohertz, and carrier spacing is 10 kilohertz. Intermediate frequency is 455 kilohertz. Signal bandwidth is 10 kilo. So we know that the bandwidth of AM signal is given by 2 FM. So it is 2 FM. So 2 FM is 10 kilohertz. So bandwidth is 2 FM. 2 FM is 10 kilohertz, and the message signal frequency is 5 kilohertz. Message signal frequency is 5 kilohertz, and modulation index for standard AM is mu is equal to 1. Next question. So a NOR gate with 3 inputs ABC, for which combination of input the output is high. So let us see the truth table for 2 input NOR gate and 3 input NOR gate. For 2 input NOR gate, 0 0 is 1, and 1 0 is remaining all the combinations, output is 0. Similarly, for 3 input NOR gate, for all 0 combinations, output is 1, and for all the remaining other combinations from 0 0 1 to 1 the output is 0. For a NOR gate, the output is 1 if all the inputs are 0. So option 1. Next question. The power gain of half wave dipole with respect to isotropic radiator. So power gain of half wave dipole. So the directivity of half wave dipole with respect to isotropic radiator is 1.64. It is a standard value, and directivity D is 1.64. 10 log of 1.64 is 2.15 dB. The correct answer is 2.15 dB. Next question. Two impedances are given and they are connected in parallel. So impedance Z1 is 10 minus 10 ohm, J10, and impedance Z2 is 10 plus J10 ohms. So then equivalent impedance is Z1 minus Z1 Z2 product of Z1 Z2 10 minus J10 10 plus J10 by Z1 plus Z2 10 minus J10 plus 10 plus J10. So after calculation, its value is 10 ohms. So that is 10 plus J0 ohms. Correct option is 3. Next question. So Norton's equivalent circuit. So the dual of Thevenin's equivalent circuit. So Norton's and Thevenin circuit has relation. So Norton's equivalent is different from Thevenin's circuit. It is not same. It has a relation, and it is a reciprocal. It is not a reciprocal. So Norton circuit and Thevenin circuit are dual to each other. In Norton circuit, VTH is the Thevenin's voltage, and Thevenin's voltage is connected in series with the Thevenin's resistance. In Norton circuit, Norton current IN is connected, and the resistance is Thevenin's resistance is RTH is RN, or Thevenin's resistance or Norton resistance. Both are same. Here voltage source in series with the resistor, here current source in parallel with the load resistor. So this Norton circuit and Thevenin circuit are dual to each other. So the correct option is 3. Next question. If if 3 resistors of each 16 ohm are connected in parallel, then equivalent resistance is. So if there are n number of resistors, if all the resistors of equal resistance and are connected in parallel, then equivalent resistance is R by N. Here 3 resistors, each resistor of 16 ohm are connected in parallel. So its equivalent resistance is 16 by 3. So its value is 5.33 ohms. The correct option is 2. Next question. Find the channel capacity in megahertz if channel bandwidth is 20 megahertz having signal to noise ratio of 102b. As per Shannon-Hartley theorem, channel capacity C is equal to B log to 1 plus signal to noise ratio bits per second. So given bandwidth is 20 megahertz, so 10 power 6 log 2 1 plus signal to noise ratio, that is 1023. So log base to 1024. So 1024 is 2 power 10. So that is 200. So its value is 2 power 10. So it will value become 10. Log 2 1024 value is 10. So 200 megahertz, sorry, 200 bits per second, megabits per second into 10 power 6 bps, bits per second. Our channel capacity is 200 mbps. So 200 mbps. So correct option is 1. Next question. Faraday law in differential form. So Faraday's laws in differential form is del cross E is equal to minus dou b bar by dt in differential form, or closed line integral of E bar dot dl bar is equal to open surface integral of minus dou b bar by dou t into ds. So this is the integral form of Faraday's law and this is the differential form of Faraday's law. So correct option is 2. Del cross E is equal to minus dou b bar by dou t. Faraday's law in differential form. Next, maximal divergence equation for magnetic field. So maximal divergence equation for magnetic field is del dot b is equal to 0. Similarly, the maximal divergence equation for electric field is del dot d is equal to rho v, that is Gauss law. Second option is the correct one. Next question. The effective aperture area of an isotropic radiator is. So generally the relation between directivity and effective aperture area is given as directivity D is equal to 4 pi AE by lambda square into effective aperture area 4 pi by lambda square into effective aperture area. So for directivity of isotropic radiator is unity. So directivity is 1. So 4 pi AE by lambda square. So effective aperture area is 1 by 4 pi lambda square. So its value 1 by 4 pi is 0.00795 lambda square. Approximately it is 0.08 lambda square. 0.08 lambda square, option 4. Next question. The MKS unit of magnetic field. So ampere is a unit for current, Weber by square meter is a unit for flux density B, and Weber's unit for flux, and ampere meter is a unit for magnetic field intensity H. So the unit of magnetic field intensity is ampere per meter. So the one more unit for flux density is Tesla, or Weber by meter square. Next question. Two sinusoidal waves of voltage V1 and V2 connected in parallel having inductance of 2 omega. The value of inductance is, here given voltage sources are having same amplitude, same frequency, and are connected in parallel. Here frequency is 100, omega is 100 here, 2 pi omega is 100 and 2 pi omega is also 100. So the frequency of voltage sources is same and the amplitude of voltage sources is same, and those two voltage sources are connected in parallel. Given inductive reactance XL is 2 ohm. So XL means inductive reactance, that is j omega L is 2. Apply modulus on both sides. So modulus of j omega L is equal to mod 2, that is 2. So omega L is 2 ohms. So what is omega here? Omega is 2 pi f. Its value is 100. So inductance L is 2 by 100. So that is 20 millihenry. So correct option is 2. Next question. So voltage reflection coefficient in terms of characteristic impedance Z0 and load impedance ZL of a transmission line. So voltage reflection coefficient gamma is equal to ZL minus Z0 by ZL plus Z0. So where ZL is load impedance in ohms and Z0 is characteristic impedance. So third option is correct. Given graph having 12 branches and 4 nodes, find the number of links. So in a graph, if number of links is equal to branches minus nodes plus 1, b minus n plus 1. So branches are 12, nodes are 4. So total number of links is 12 minus 4 plus 1. So that is 9. Correct option is 2. Next question. The equation del square V is equal to minus rho V by epsilon is called Poisson equation, where rho is a volume charge density. So Laplacian equation is del square V is equal to 0, and continuity equation is del dot Jc. Conduction Jc is conduction current density is equal to minus dou rho V by dt. This is in differential form, and integral form for this continuity equation is closed surface integral of Jc ds is equal to minus dou by dou t volume integral of rho v into dv. So here it is Poisson equation. The correct option is 1. Next question. The stability factor of typical amplifier using self bias lies in between. So the stability factor of fixed bias is S is equal to beta plus 1. Collector to base bias or collector feedback bias is S is equal to 1 plus beta by 1 plus beta RC by RC plus RB. So here they have given self bias or voltage divider bias stability factor. S is equal to 1 plus beta by 1 plus beta RE by RE plus RB. Take RE to the denominator or RE as common. So this equation will become like this. If RB by RE is very much smaller or less than 1, then stability factor, so if it is much less than 1, so its value becomes 0. 1 plus beta by, so its value become 1. 1 plus beta by 1 plus beta, so numerator and denominator are same, so it will become, stability will become 1. If RB by RE tends to infinity, then stability approaches to 1 plus beta. So for a self bias or a voltage divider bias, the value of stability may lie between 1 and 1 plus beta. 1 and 1 plus beta. So correct option is 4. Next question. The maximum usable frequency of an ionospheric layer at 60-degree angle of incidence with 8 megahertz critical frequency. So critical frequency is 8 megahertz. Given critical frequency is 8 megahertz and angle of incidence is 60 degrees. They are asked to calculate maximum usable frequency. Maximum usable frequency is equal to critical frequency into secant theta. So this is a relation. So critical frequency is 8 mega secant 60 degrees. So secant theta is 1 by cos theta, cos 60 is sin 30, sin 30 is 1 by 2, and its value is 16 megahertz. So the correct option is 1. Next question. A transmission line having 50 ohm impedance is terminated with a load of 40 plus J30, and they are asking to calculate the voltage standing wave ratio. So voltage standing wave depends on reflection coefficient, and reflection coefficient in turn depends on load impedance and characteristic impedance. Here reflection coefficient gamma is ZL minus Z0, having a load impedance. Load impedance is 40 plus J30 ohms. Characteristic impedance is 50. So for ZL minus Z0, ZL plus Z0. So this is reflection coefficient. So it will become J30 minus 10 ohm, J30 plus 90 ohm. So modulus of reflection coefficient, apply modulus on both sides. So on calculation, modulus of A plus IB is square root of A square plus B square, where I is a complex operator. So apply this modulus on both sides, we will get magnitude of reflection coefficient is 1 by 3. So from this magnitude of reflection coefficient, we will get standing wave ratio is 1 plus 1 by 3, 1 minus 1 by 3. So its value is 2. The correct option is 4. Next question. A 3 microfarad capacitor is charged by a constant of 2 microamperes for 6 seconds. the voltage across the capacitor at the end of charging. So that is final voltage. We know the current through capacitor is I of t is equal to C dV by dt, and voltage across the capacitor, this is a differential form. Apply integral on both sides, and voltage across the capacitor is 1 by C integral 0 to t I dt. So what is the capacitance value? It is given as 3 micro, that is 10 power minus 6. So it starts from time t is equal to 0 to time t is equal to 6 seconds. These are the time limits. So for 6 seconds, this is the time limit. Next, current is 2 micro, 2 into 10 power minus 6 dt. So its value is 4 volt. Voltage across the capacitor is 4 volts. Next question. Degaussing coil is used in color TV tube to reduce the effect of Earth magnetic field. So these degaussing coils or demagnetizing coils are provided on a color picture tubes for removing stray color effects on screen caused by the stray magnetic fields or ambient magnetic fields. So correct option is 4. Next question. In India, TV channel bandwidth is 6 megahertz. So this is 6 megahertz. Next question. In a TV receiver, the contrast is controlled by either variable resistance or AC voltage in the video signal. So correct option is 4. DC voltage is wrong and signal brightness is wrong. In FM, the carrier deviation depends on. So FM is frequency modulated signal. So for a frequency modulated signal, carrier deviation is delta F. So delta F is given as KF into AM, where KF is frequency sensitivity, units are hertz per volt. AM is the amplitude of message signal. So frequency deviation is measured in hertz. So modulation index beta is delta F by FM. So in the question they have asked frequency deviation delta F. So delta F depends on KF as well as AM. Carrier frequency deviation depends on amplitude of the message signal. Derivative of modulating signal is wrong. So correct option is 1. Next question. For an FM wave, the modulating frequency of 10 kHz and bandwidth of 2 MHz. If a modulating signal amplitude is doubled, then bandwidth. So given frequency of message signal, so FM is 10 kHz and given bandwidth 2 megahertz. So bandwidth of frequency modulated signal, it is given as bandwidth is equal to 2 into beta plus 1 FM. So bandwidth is 2 megahertz, 2 into 10 power 6, 2 into beta plus 1. So FM is 10 kilohertz, 10 power 3. So from this, beta plus 1 is 100 and beta value is 99. So if message signal amplitude is doubled, so message signal amplitude becomes doubled. So we know beta is equal to delta F by FM, that is KF into AM by FM. Here AM gets doubled. If AM is doubled, obviously beta gets doubled. So in that case, bandwidth is 2 into beta dash. So let us assume this beta dash is equal to 2 beta. 2 into beta dash plus 1 FM. So 2 into 2 beta. So that is 198 plus 1 into FM. So FM is 10 kilohertz. So the new bandwidth will become 198 plus 1. Beta dash is 198 plus 1. So the new bandwidth will become 3.98 megahertz. So 3 3980 kilohertz or 3.98 megahertz. Correct option is 4. Next question. The Fourier transform of a function, inverse Fourier transform of a function 2 by j omega is. So generally we know for a signum function, Fourier transform of a signum function is 2 by j omega, and inverse Fourier transform of 2 by j omega is signum of d, signum function. So these are signum function here. So for signum function, t less than 0, its amplitude is -1. At t is equal to 0, its amplitude is 0, and t greater than 1, its amplitude is, so t greater than 0, its amplitude is 1. The Fourier transform of unit step function is pi delta of omega plus 1 by j omega. The correct option is 3. So similarly, the Fourier transform of delta of impulse signal is 1, and Fourier transform of rector signal is tau sync omega tau by 2. Recto t by tau is tau sync omega t by 2. Next question. If f of t and f of omega are Fourier transform pair, then Fourier transform of f of t is, it's a duality property. So duality property of capital F of t. So this is capital F of t. So if Fourier transform of small x of t is capital X of omega, then Fourier transform of capital X of t is 2 pi small x of minus omega. So if the signal x of t is even signal, so x of minus omega is x of omega. The duality property of Fourier transform for even function is 2 pi x of omega. Since x of minus omega is equal to x of omega, the correct option is 1. If Fourier transform of f of t is f of omega, small f of t is capital F of omega, then Fourier transform of capital F of t is 2 pi f of minus omega. It is a duality property of Fourier transforms. Next question. So given slew rate of an op amp. So slew rate of an op amp is defined as the maximum rate at which op amp output signal can change, or the speed at which op amp output voltage can change. So it is given as slew rate is equal to dV0 by dt, that is maximum current by capacitance. Given maximum current is 32 picoampere and capacitance is 6 microfarad, they asked to calculate the slew rate in microvolt per second. Slew rate is defined as maximum rate of change of output voltage or maximum speed at which op amp output voltage can change. So it is given as slew rate is equal to dV0 by dt, maximum rate of change of output voltage in of op amp, that is dV0 by dt. So it is equal to maximum current by capacitance. So generally units are microvolt per second. 32 pico by 6 micro, 5.33 10 power minus 6 volt per second, or 5.33 microvolt per second. The correct option is 1.